Hey everybody, so today this is what we've been doing. Make sure you guys go ahead and finish up that web quest. That web quest and the stuff that you learned on that web quest will come in handy on all of this good stuff. So these questions 1, 2, and 3, what this is pretty much a bell ringer over the rock cycle and things like that. 2, this one's one that we've gone over. It's kind of tough, but the key is it's a sample of something that only is made up of one kind of atom. Okay, what type of mineral is that? Here, state 2 things that must occur to change sediment into sedimentary rock. So it's already turned to sediment. So we know that sediment is formed from weathering and erosion, right? Weathering's that process of if you think about mountains or anything, right, especially here in the Midwest where we get snow, we get ice during the winter, and then it all melts away, gets super hot. So we get ice, let's start out with water. Water gets into cracks, and then over the winter it freezes and it expands. We know water expands, and as it expands, it forces these cracks to get bigger and wider, and then it'll melt again. And then that water will melt and go deeper into that crack, and it'll freeze again, and then it'll widen that crack even farther. And this happens over years and years, hundreds of years, thousands of years, tens of thousands of years. And then eventually we just break everything down, and that's the weathering part, right? Water, wind, and all that stuff. And then the erosion is the actual picking up of that sediment and taking it somewhere else. So it breaks down. If you think about the mountains, the snow melts on the mountains and it picks up the sediment that it melts with and washes it down these creeks into these streams that end up into big rivers and such things. And then, so what's the process that's called that these sediments turn into sedimentary rock? Just a second, I'm making a video here. Give me 1 second, guys. I'm making a video. So, next, you guys need to read this section right here. It says, you're a volcanologist studying the eruption of Mount St. Helens that occurred approximately 20 years ago in Washington State. So go ahead and read this little portion here. Then you guys need to make a graph with the following information. So I have a graph paper, and so you'll have crystal size right here. You have time and years right here. And if you notice, our time in years has a big difference. You go from 0.01 all the way to 997. So that's a big range of numbers. And so that's why our graph looks a little funky. It has a whole bunch of little lines. Well, this is called a logarithmic graph. It's no biggie. We're really not going to run into this a whole bunch. I'm not going to go into all the mathematics of it. But all it does is our years, the one that actually has the big range of numbers, this is the one that goes by multiples of 10, right? So if I go here, if I go 0.01, this next line right here is 0.02. This next line right here is 0.03. This next line 0.04. 0.05, 0.06, 0.07, 0.08, 0.09, and then 0.1. And now it changes from here to here. Now we go 0.2, 0.3, 0.4, right? Then we finally get to 1. And then these go by ones, 1, 2, 3, 4, right? And then we go to tens, and these go by tens, 10, 20, 30, 40, 50, right? And then we go to up another power of 10, 100, 100, 200, 300, 400, so on until we get to 1,000 up here. Okay, these numbers down here, crystal size, these guys stay the same. Okay, these intervals stay the same. But in between these intervals, we have 4 lines, right? So these are actually intervals that go by 0.2. So if I go 0, 0.2, 0.4, 0.6, 0.8, 1, then 1.2, 1.4, 1.6, 1.8, 2, so on and so forth. Okay, so if I go to do this next one with you, give me 1 second here, and I'll want to increase my pen size. So my first crystal size is going to be 0.2 millimeters, and then my first year is going to be 0.01. Okay, whoop. So let me erase this, get all this stuff out of the way. So my first year is here, 0.01, and then my first year was, my grain size was 0.2. So there's my first point. Next, my next one is 1.2 in crystal size, and then my years is 0.1. So what I'll do, why do I keep doing that? and then I'll go to 0.1. So then I go back to my graph here. So I get my 1.2, and then it goes up here to 0.1. Okay, and you're going to keep on going. So like your next one's 3 years. So you'll go 1, 2, 3. So there's 3 years, and then your other one, I forgot what the other point is. So you guys are going to keep on going up. Okay, and so just keep going with this. Don't worry about why are these lines getting thinner and thinner as they get towards the top. That's a mathematical explanation that I don't know 100%, but we really don't need to know that right now. We're just graphing how big the crystals get as they begin to cool down over a slower amount of time. So then after you guys get done graphing that, we haven't got really close. That's about as far as we got today in class, but we will finish this on Wednesday. So go ahead. You guys can move on, but this is still due for you guys on Wednesday. When you guys go to answer these questions, like what's the relationship between the time it takes an igneous rock to cool and its crystal/grain size, you guys need to refer back to this graph and back to this table here. All right. And all of these questions are going to talk about these. Okay. And then it has some more of this. And then you guys are going to do this all on your own. Okay, and you'll upload that to Teams for Wednesday. If you guys have any questions on that stuff, let me know. Message me. All right, bye.